Okay, I'm going to do a quick overview of your Geometry Lesson 1 from the week before spring break. I already have everything worked out, so you can kind of just scroll through and check your answers if you need to, or if you need to hear an explanation, I'll go through the explanations. Most of these triangles were the special cases of the 30, 60, 90 that you see here, and then we also worked on the 45, 45, 90 triangles before we left for quarantine. Okay. So for this one, if you notice, it's a 30, 60, 90 here. So as soon as you see that 30, 60, 90, go ahead and write out this ratio. X square root 3, and 2x. 2x, your longest side, is always your hypotenuse, which is what's given to us here. So I set my 2x equal to 4, found my x, which then was my short side here. But then all we have to do is plug in that x right here to get our longer side. So to find each leg, we found that we have 2 and 2 square root 3. If you can remember this ratio, 30, 60, 90, they're pretty easy. All right, number 2. Lynn missed class and Tyler is helping her use the table to approximate angle measures to have the ratio listed. Tyler says you can use the right triangle table to figure this out. Lynn notices that the ratios are the same in each row. Estimate the angles and explain why you know the values. Again, these are estimations. It's approximately 55 degrees, approximately 35 degrees. What they're talking about is these two are the same. But remember, if you have complementary angles, if I'm looking at this angle, then this is my opposite side and this is my adjacent side, or this is my hypotenuse. The reason they're going to be the same ratios, them complementary angles, is let's say this is my 55 degrees here, then if I go to the other side, this is going to be my 35 degrees, but now this is my opposite and this is my adjacent. So we have flip-flopped what's opposite, what's adjacent, and hypotenuse stays the same. So we'll get the same ratio here and here. Okay, for those of you that did this and that I've graded and gave feedback before spring break, this is part of the area that y'all struggled with a little bit, and it wasn't terrible by any means. But let's kind of go over 3, 4, and 5. On 3, again, we talked about if we have an equilateral triangle and we have an altitude, then we have a 30, 60, 90 triangle here. So again, if you have a 30, 60, 90 triangle, then you have this ratio. If you're given one side, then you have actually all 3 sides. So again, we're given the hypotenuse again. So I worked that out over here and found that my short side would be 4, my x would be 4, which then, once I have that, then I immediately have my longer side, which is 4 and square root 3. And again, the measure of angle B will be 60 degrees because it's an equilateral triangle, so all measurements are 60 of the big triangle. Okay, number 4, the quilt is made of squares with diagonals. The length of BD is 4, and I drew that down here to show kind of the separation of what's going on here. They gave us this long diagonal piece here. So a lot of y'all, I think, figured that to be the small one, and then you calculated the smaller triangles with this hypotenuse being 4 and not the long one being 4. So I drew it down here, and so if we have a square, then we know we have a 45, 45, 90. And the ratio we learned for that was x and x square root 2, with x square root 2 being our hypotenuse. So I solved for my x value here. X square root 2 equals 4, so I isolated my x. So 4 divided by square root 2, and then I went ahead and multiplied both sides by square root 2 to rationalize this fraction. And to simplify, we actually get 2 square root 2. Okay, remember, whenever you multiply square root to square root, I'll make a note of this, I'm going to erase it, but remember, you multiply the two numbers that are underneath the radical So then we get 4, but square root 4 is just 2. So really you're just canceling out the radical because you're multiplying the same number together and it's going to get a perfect square. All right, so that was just a quick summary, remember, of how to multiply with square roots. Okay, which means the long side of my triangle here is 2 square root 2, which means when I go back and we really only want half of that, if you go back to the quilt, we really only want half of that. So if you divide that by 2, then you're down to just square root 2, which I did that up here as well. Okay, so that's where AE is just square root 2. So then find the area of the square. So now we want to find the area of the big one. Well, if we know that the side is 2 square root 2, so that's right here, area is base times height, or s squared, side squared, so that's a square. So I multiplied my base, multiplied my height, so I multiplied the front numbers, so 2 times 2 is 4, and then square root 2 times square root 2, which again, that's going to be, like I did down here, square root 4, which is just 2, so 8 units squared. All right, and then from B is the same thing on number 5. So now I have a square, and a lot of y'all calculated this as the side length was 5, but the diagonal length is 5 here. This length is 5. So then, again, I just set it up as the ratio, x, and then x square root 2. So 5 equals x square root 2. Solve for my x, which is 5 over square root 2. Again, since we're going to be multiplying this, we don't really need to rationalize it because we're going to be doing our height times our base. So I do 5 square root 2 times 5 square root 2. So multiply straight across. 5 times 5 is 25. Square root 2 times square root 2 is 2. So 25 halves, which is 12.5 centimeters squared. All right, again, if you have more questions on that, please feel free to email me. Make sure you get this submitted this week.